Hello, I'm Jay Ingram.
And I'm Judy Halliday. Welcome to At Discovery Canada for Thursday, October 12th. Tonight, we'll take you flying. Scientists from around the world gather every year in Lynn, Manitoba. It's a tiny place that's answering some big questions. We'll find out what they are.
The Northern Lights have seen queer sights, but do they make strange noises too? You asked us, we have an answer.
And we'll take a walk in Becky's backyard. Tuesday, she was so terrified of spiders, she could barely look at them. We'll find out how she's doing after a few hours of treatment.
All of that, plus your chance to prove your math prowess on the numbers game with Nathan Davinsky. Not only can you show off, you might win a t-shirt too.
And we'll talk with a man who won a Nobel Prize this week for chemistry. Sherry Rowland helped the world understand what was happening to the ozone layer, and he'll tell us about winning the Nobel Prize a little later.
But we begin in Manitoba, where this summer scientists from around the world gathered to do tests with cosmic consequences. Now, usually if scientists want to take a look at outer space and what's going on, they have to book time on the space shuttle or get in line at the Hubble Space Telescope. But not at Lynn Lake, Manitoba, where scientists use some cheaper, less high-tech methods to carry out their experiments. We sent a high-8 camera there to find out what they were up to.
I sort of look at it as, the universe being a giant puzzle, and we're looking for another piece of the puzzle to put in place.
I think that this kind of experiment, that is ballooning, is just one of the more fun, I guess, ways of doing astrophysical research. I mean, it's sort of like going to Boy Scout camp or something for the summer.
Hold on, Gage.
Go ahead.
You got it all finished?
Yeah, they're just a minute or two away here from putting this thing together.
You don't need too much.
We fly balloons at the request of NASA. We're a customer, so to speak, of NASA. We take care of their customers, the balloon scientists, and we fly them in different parts of the world according to the science that they desire.
One of the nice things about this sort of collaboration is that you really have a fairly small team for each instrument, and in the cosmic ray field it's really a small community, and though there are 3 instruments up here, they all sort of have ties in together. This is the first time Tiger has flown. Tiger, which stands for Trans-Iron Galactic Element Recorder, is meant to look for really heavy cosmic rays, things heavier than iron. And so you need a big detector, and you need to look for a long time in order to collect enough particles to accurately measure how many you saw.
What we have here is basically electronics we bought off the shelf. All of this, what you see here, will be flying in the balloon.
What I really like about an experiment like this is that it's small enough that one person can really understand the experiment and help out, of course, across the entire range of the instrument. We regularly do everything from, soldering to actually analyzing the data to doing the real science.
I'm Jim Beatty. I'm an associate professor of physics at Pennsylvania State University, and I'm heading up the effort of the HEAT program up here. HEAT, it's the High Energy Antimatter Telescope. It measures electrons and positrons, and we're able to discriminate the antimatter, that is the positrons, from the matter, the electrons.
And it is interesting to measure the antimatter, because that could give a hint on how the universe was created. Is there a relic of antimatter from the Big Bang? It would not be impossible to have somewhere regions in the universe where you have only antimatter.
Most of cosmic ray, primary cosmic ray, consists of positive charged particles, and we are searching for negative one. So many physicists would like to understand more about this so basic and simple question.
Lynn Lake is a very convenient spot to fly these cosmic ray balloons from because the Earth's magnetic field acts as sort of a force field. It keeps out the galactic cosmic rays at low energies. The closer you get to the equator, the more it acts as a force field, and so you want to be close to the magnetic poles in order to look for the cosmic rays.
We have to know what the upper winds are. We have to know where the balloon is going to go. What we're looking at when we do these pieballs is we're looking for the direction the wind is coming from.
That we can track the balloon and keep a very accurate position, and these knobs keep track of the azimuth, the way it swings around, and the elevation up and down. And then the information goes into a computer back here, and it calculates the direction and speed of the wind at various height levels.
They're laying out tarpaulins that they'll lay the balloon on top of so that the balloon doesn't rub against the runway.
Well, we got about 5 or 10 minutes. We're going to have another one of those pieballs to get some wind speed information and directions, just to see if everything's going the way we planned it or forecast it.
Okay.
We need to switch on battery right now to operate the system. I'm asking our campaign manager whether we can switch on or not, and he said we should wait. So we are waiting for his direction.
Oh, you can see them. I mean, they are very, very uptight, and their responsibility is very, very heavy. I mean, they are a long way from home. They have an instrument. I think the expedition cost something like $5 million, and so it all depends on the success of this launch. And so I can really feel for them. It's a very sobering experience.
Right.
Virtually everything on our checklist has come about through a failure on the flight. It's a lot of responsibility to make sure it works right. You only get one chance. If anything gets screwed up, the balloon's already launched. It's in the air, so you can't recover it. So you've got to be perfect every time.
After putting some cap, we are ready.
Okay.
So we are being ready.
So I can tell Donald you're ready now?
Another 1 minute.
Yeah. Hell, he had something, what, 299 or 2 something, 90?
299, 310, 302 or something.
Yeah.
13 knots.
I don't believe the 13 knots myself. What do you think?
Wait and see what it does.
Gonna wait another 15 minutes? Yeah. Want another pieball?
Yeah.
We're looking at the winds. See what the final layout's going to be if we're going to do it. And if everything's going great, then Donald will start the crew laying the balloon out. It'll spread out all the way down the length of the tarmac here. And then he'll hook it up to the top of the parachute. Then after everything's all set out, everything's ready and they're ready, we'll start the inflation.